Hello there, I'm Thomas. Hatsio, the British American pilot flying the Boeing 777-300ER international flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport. Runway 1449, let's localize and landings. Right now I'm in the cockpit for the pre-takeoff preparation of the PMDG simulation and microflight simulator X Boeing 777-300ERX. I'm going to start showing you the cockpit instruments that displays the functions of the Boeing 777-300ER jet aircraft. I'm going to start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric pressure of the outside atmosphere, and the barometric altitude of the outside level. Also the target altitude selected from the autopilot and flight director system panel. We have the vertical rate of climb of the aircraft in 10 hundredths of feet per minute in steep angle in degrees, and also the magnetic heading and track, the magnetic north pole and true north pole, and the magnetic variation depending on where we are in the world. We have the pitch altitude in degrees and the bank angle in degrees in the attitude indicator. Also the flight director crossbars and the ILS crossbars for manual guidance of the aircraft, and we have the autopilot guidance crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode on zero with the autopilot and the autothrottle. Later on vertical navigation modes. We have the navigation display. The navigation display that displays the airport, the waypoints, the GPS position of the aircraft, the NP and the RNT, the required navigation performance, the required navigation performance. We have the weather reflections and the terrain reflections from the weather radar. So you can see the elevation of the terrain around you with red, yellow and green color, and also see the lake and other information. You can see here the primary flight display, the navigation displays. So we have also the autopilot and flight director system panel in the upper and the lower ACAS. It's indication for this system display. So you will see also other aircraft flying around our aircraft, the distance they are located, their direction, the altitude difference from our aircraft, and the TCAS system, traffic collision or arrest system warnings. We have the transponder, the ATSP and ATSC transmitter receiver transmission receives our own position and altitude and direction, and transmits to other aircraft and the air traffic control. So you will see the other aircraft in the navigation display. You will see also the magnetic heading and track, the magnetic north pole and north pole magnetic variation depending on where we are in the world again. The next waypoint we're going to be overflying the ground speed of the aircraft and the wind direction and vector. So we have the flight management computer. We're going to input all the data of the aircraft, like the takeoff weight, that includes the empty weight plus the passenger plus the fuel plus the trip fuel plus the taxi fuel plus the reserve fuel. So we have the takeoff weight. We're gonna use the data of the runway we're gonna use for takeoff, like the runway length, the runway condition, if it is dry, wet or ice, the wind direction and speed, and also the barometric pressure and barometric density, the air density, and the temperature. Here we have also the mean aerodynamic core position of the aircraft. This is going to be calculated using the flight management computer automatically, using the gross weight for takeoff and other data. Also the horizontal tail elevator trim position for takeoff. All this is going to be calculated using the flight management computer. It's going to give us the speeds for takeoff for this runway, for this airport. So we're gonna have the takeoff speeds, the V1, V-rotating, V2. Also we're gonna have the flaps position for takeoff and other data. And then the flight speeds, like the cruise, the climb, the cruise, the descent and the approach speed. So we're gonna have also, we're gonna select using the flight management computer. We're gonna select the departure airport and runway. The seats, the standard instrument departure waypoints and fixes, intermediate waypoints and fixes for the destination airport and runway, and also the stars, the standard terminal arrival and standard terminal arrival fixes and waypoints, and the Lszh localizer frequency for the destination airport runway we're gonna select. So we have a horizontal localizer and a vertical glide slope to guide us using the radio frequencies into the runway we're gonna select. Also, we're gonna have the autopilot and flight director system panel, the FPS. I will show you that also. That contains the autopilot engage and disengage switch, the auto throttle left and auto throttle right engage and disengage switch, the flight director engage and disengage switch. We have also the airspeed select knob. We're gonna select an airspeed in nautical miles per hour knots or Mach speed, and we're gonna select some modes like the flight level change, the auto throttle with the speed mode, and the climb continues. So we have two main modes of speed guidance that commands the engines of the aircraft, the turbo handle engines, and the auto throttle and the auto thrust system, and also the thrust levers that move either manually or automatically, so we can adjust the thrust and the airspeed manually using our hands to move the thrust lever, so we can use the autopilot flight director system panel with the auto throttle and select an airspeed. So we have two modes, main modes like the takeoff go round and the climb continuous, that uses maximum continuous thrust, which is a fixed thrust mode. Also, the idle thrust for descent is a fixed thrust mode, and using the fixed thrust mode like the climb or the descent, the thrust produced from the engine is continuously the same. So the airspeed is being adjusted by varying how fast, how steep the aircraft climbs or descend at a trigonometric angle in degrees, or in a vertical rate of climb descent in tens, hundreds, or thousands of feet per minute. We vary how fast it climbs or descends, and this allows us to vary the airspeed using fixed thrust. We have also the variable thrust modes like the cruise and the approach for landing, in which the aircraft attitude is constantly the same. Like in the cruise level, it flies straight and level, but the airspeed is being adjusted by varying the thrust produced by the engine. The N1, which is the low speed starter and shaft and compressor and turbine of the turbo engine, and the N2, because we have the General Electric 90C90 turbo engine, so the ATR engine power rate in other like the Rolls-Royce engine. So we have also the LNAV and the VNAV, the lateral navigation and the vertical navigation of the aircraft, which is interconnected to the flight management computer, the FMC. We input the FMC CDE over here. So you can see here's the autopilot and flight director system panel. I will show you all the functions we have. The bank angle limit select for the cruise level. We have also the heading select, the heading hold switch. We have the FPA, the flight path angle in degrees. We can select how fast the aircraft climbs or descends in a trigonometric angle in degrees, the steepness of the angle in degrees of the climb or the descent, or tens, hundreds, and thousands of feet per minute for climb and descent rate. Vertical speed indicator. You also see the vertical speed indicator over here in the primary flight display. So I will show you later that also. We have also the altitude select knob and the altitude hold switch, the target altitude from the autopilot panel, and the Vorlock with the Lszh localizer function, and the approach switch for the auto land function of the Boeing 777-300ER. Then I'm going to show you the thrust levers, how you can adjust, how you can use the thrust levers over here to vary the thrust produced by the engines. The turbo engines, one installed on the left wing, one on the right wing for symmetrical thrust and redundancy. Also other things like the flight controls, also the control column we use for controlling the horizontal tail, the elevator, and also the pitch stream to adjust the pitch stream stabilizer position, which is the horizontal tail position. Also, we have the irons and the spoilers in the left and the right wing, which is used for bank roll turns, and we're gonna use the control wheel for that. So we use the control column in the yoke of the Boeing 777 300ER. We use the control column for the horizontal tail to climb or descend the aircraft, and also the ailerons and the spoilers to down roll. We use the control wheel. So we use also the rudder pedals for controlling the vertical tail, the stabilizer of the aircraft, the vertical stabilizer. So we use the horizontal stabilizer over here, climb and descend using the control column, and you use the vertical stabilizer here using the rudder pedals left and right. And also we have the bank roll right and bank roll left using the ailerons and the spoilers in the left and right wing. Also the horizontal trim stabilizer here, this switch, you see also here the position of the horizontal trim stabilizer. I will talk to you about later. Then I'm going to show you the flaps and the slats, which are circulatory flight controls. I will tell you about the flight theory of the aircraft, about the newtons per second low kinematics of motion, about the Bernoulli theory of fluids. I will talk to you about aeronautical and aerospace engineering and aerodynamics. So I will show you also how we calculate the takeoff speeds. I will turn off the engines of the aircraft and make an engine start, and I will show you how to start the engines of the aircraft. And then I will show you the overhead panel, the systems, the electrical, the left and the right engine driving IDG. We have 120 200 volts alternate current, 120,000 kilovolts or 120,000 watts is the left and right engine. Produce alternate current for 100 hertz, three-phase current. We have also the backup generators, 25,000 kilovolts, and the APU, the auxiliary power unit, we need for starting the engines, another 120,000 kilovolts. Also the batteries. The batteries 28 volts, 48 ampere hours of direct current. So we have also the ability of data user reference unit, the flight control computer, also in the overhead panel of the system. The electronic engine control for the engines, the FADEX. The FADEX are the full authority electronic control computers, one installed per engine. Dual the engine redundancy, when the engine fails, if one time fails, the other takes over. So you will see all the information, the upper and the lower ACAS is being displayed by the FADEX, which are installed in the engine, one in the left engine, one in the right engine gearbox. Also the IDG, the great drive generator, also driven by the engine that produce alternate current. Also the hydraulic pumps, the left and the right engine, and the electrically driven. Also the hydraulic fluid is pressurized from bleeder from the 5th and 9th stage of the engine. You will see also that. So you will see in the overhead panel the systems, the left and the right engine, electrical, the batteries, the APU, the auxiliary power unit, the ADIRU, the air data announcer reference unit, the hydraulic pumps, left engine, right engine, C1 and C2, the electronic engine control for the engines, the fire extinguishers, the left and the right wing fuel tanks over here. I will talk to you about the fuel booster pumps, about the low and high fuel pressure fuel valves, and also the crosswind valve between the left and right wing, which is used to stabilize, to balance the fuel between the left and right wing, or as a backup if we have a failure of the fuel booster pumps in one wing tank. We can feed either engine from the left or the right wing using wing tank using crosswind valves. Also we have the center tanks in the fuselage of the aircraft. We have the cabin pressurization system. We can dump some fuel inside. I will show you also that over here. So here's the fuel system, the hydraulic, the electrical, the pressurizer, the bleeder from the left and right engine. We use the bleeder from the 5th and 9th stage for cabin pressurization, wing and engine 98 eyes, air conditioning and ventilation, hydraulic fluid pressurization for the hydraulic fluid tanks. Also for starting the engines using the APU. The APU is a small auxiliary power unit in the tail of the aircraft, a smaller turbine, which is used to start the engines in the ground. To pressurize the left and the right engine starter, which needs pressurizer and also electric power, alternative electric power from the APU. So I'm gonna show you how to start the APU and the batteries and then start the engine. The hydraulic system, the hydraulic fluid for the flight controls and other units, other systems, the fuel tanks also. So thank you very much for joining me in this video. I'm Thomas Hatsio, the British American pilot flying the Boeing 777 300 ER into night flight. So I'm gonna start showing you now all the systems. So we'll start here. So we have here, you can see about an hour left for this flight. So you can see also the outside view and the airport view as well. So also the aircraft, all the flight controls movement. So we have here is the aircraft inside the cockpit, like the view. So we start with the primary flight display. You can see here here's the airspeed indicated, the airspeed tape, the ground speed here selected from the autopilot flight director system panel, the radio altitude above the ground level, the magnetic heading can track the magnetic north pole and true north pole and magnetic variation. Depending on where we are in the world, we can see also that in the navigation display. So we can use either magnetic north or true north. Like now you have the geographic north pole for navigation. So you can switch either one here, true or magnetic. So you have some small difference in this place. We have also inches, hectopascals, inches of mercury for the barometric pressure, and set the barometric pressure for the barometric altitude calculation. So we have 1430 feet with 29.92 or 1013 hectopascals. So we have also the target altitude 10,000 feet. We can change all these values, use different values in a couple of minutes. So we have also the pitch ladder in degrees. You can see 2.5 degrees tick marks here. 2.5, 5, 7.5, 10 degrees, 12.5, 15, 17.5, 20 for plus climb or descent. And you can see also the vertical speed indicator, how fast you climb. The needle moves up here in the positive value, so if you descend it moves here in the negative value. So you have to pay attention to the difference between your pitch altitude, your airspeed and your vertical rate of climb and descent if you want to maintain the flight safe. So you have also the altitude, also the flight mode annunciator with the takeoff go on right now arm, the autopilot and the auto throttle. The flight director now we can change the autopilot over here, and here you can see the terrain map, the information, the airports with the GPS receivers, the terrain elevation. You can see from the weather radar some reflections. This is the ground level. With red is 6,100 feet, with yellow is the intermediate, and with green is the 0 feet. So you can see the distance, like 160 nautical miles, 80, 40, 240, 330, and you can change that. Also the degrees, magnetic heading and track again. We can see an aircraft is coming in. So we see here, if we see here the distance, you will see the aircraft is coming in. You will see the navigation displays 10 nautical miles away is plus 2,800 feet. You can see the diamond over here that represents the aircraft is plus 2,700 feet above our own elevation, and it's closing in this direction in front of you. Now it's like 9 nautical miles. We will see different information in a couple of minutes. So we have the flight director. We can also change here. We have the auto throttle left and right, auto throttle left off over here, and auto throttle right. You see auto throttle left off and auto throttle right off, like this, both off and one auto throttle off. You can see the warning. Also we have this knob, both off, flight director off. You can also set an airspeed, flight level change. Indicated airspeed or Mach, and we can see now the aircraft is 5 nautical miles away. You can see it's 2,200 feet. You can see the terrain level now 031 is 3,100 feet, and 018 is 1,800 feet. Is in front of you 5 nautical miles. Also the aircraft is plus 1,800. Is descending. You can see the arrow down is indicating is descending flight path plus 1,600. Plus 1,500, plus 1,400, and it's closing in, and it's in front of you here. You can see the aircraft is coming in. It is coming for landing over here. So now it's 2.5. You have to make it closer. The indication over here. Now it's plus 900 feet. It's in this direction where our airport is. You will see the traffic, the alert with the yellow when it's closing in closer, like now it's less than 2.5, between 5 and 2.5. In this side now it's about 1.5 nautical miles away, and it's plus 500, plus 400 feet, plus 300. You will see the warning here generator. Here is the traffic. So you see now the traffic alert here is here, and it's coming in. Plus here's the traffic we spotted in the navigation display. So you can have an awareness when an aircraft is coming in. Also we can switch out now the distance. Also we have 28, and we have about 30 minutes to start the aircraft full flight. So we have the bank angle also. You can see this switch also is the purple. So we're gonna set also the auto here, heading and track. the altitude 35,000. The altitude hold, other one is also depressed. Well, you can switch this out, and also the vertical speed. So we have also flight path angle, vertical speed. So we can also turn on the autopilot like this. You press this switch here, you see both sides. The autopilot is on, and we can disengage. So you see the autopilot now connected, flight level change, speed heading. This is the airspeed target, the altitude 35,300 feet or 7,710 meters. So we're gonna use also other indications, the heading hold, also like level change, speed again, the altitude hold. And we can use also the flight director with the same thing. We have the autopilot, the warning, and the autopilot is disconnected like this. You will see autopilot disconnect. So we cancel the warning and we reset the autopilot. So we have about 39 more minutes. So also flight director now, altitude, flight level change, speed. The flight director for manual guidance, and also vertical speed, flight path angle. You will see that also you can descend or climb, so you have to move the slider up and down. This slider over here, and you have the degrees, how many degrees you like it. So you see here flight director, flight path angle, or the autopilot on. You have the autopilot connected like this. You have the AP on, flight path angle, and you will see the flight path angle in degrees over here is descending, is below the horizon line, is -3.5 degrees. This purple tick marks 1013 hectopascals or 2992 inches of mercury. So we have the autopilot again, flight path angle, and now we can use the positive decline. We will move the slider the other way. You will see plus 3.5 degrees, the plus sign over here. And you will have the blue, you have the purple over here in the blue. You see this purple lines is plus 3.5 degrees. For climb with the flight path angle, the heading select, and this is the mode for navigation. Also we have over here, we can use this mode. We can use the vertical speed in tens, hundreds and thousands of feet per minute, like this, -3,500 degrees, -3,500 feet per minute. You will see the vertical speed indicator over here. The purple line indicates descent. Also we can use so you have the VS now, the vertical speed. We can use the other side, a climb. So this is how to use the autopilot of the Boeing 777-300ER and the other instruments like the primary flight display, the flight mode annunciator, or basic instruments, vertical speed to 253 knots, 35,000 300 the target altitude, and this is the rate of climb of the aircraft, 3,500. This tick mark here. So we have again the flight level change. One more time, the altitude over here, target altitude. As you can see, target altitude. So you see the altitude now. Also the flight level change. So this is all the modes we have to use. Flight level change speed with the autopilot and the auto throttle, which also interacts with the thrust lever. So we can disengage the autopilot. As I saw you, we press this switch. We have the warning over here, and you can see the autopilot disconnect over here with the red letter. Also we can reset one more time. Press the autopilot here, the auto throttle and the autopilot switch here is on. We can press this switch here in the control wheel of the aircraft. So we press this switch here one time. This also disconnects the autopilot. You will see the warning again, the autopilot disconnected with the red color. And we press one more time over here, this small switch, and this causes this confirms the autopilot disconnect action and cancels the warning. So we have manual flight controls. So we have also, I have to show you quite fast now. We have about so we have before takeoff we have like 25 more minutes. So we can see another aircraft coming in. I will have to talk to you about the thrust levers. So we see the aircraft here. We can see also in the navigation display. I'm gonna have it coming in. You see it is plus 2,700 here feet, less than 10 nautical miles away. Now it's 2,700. So you also have to know how to use the thrust levers and the other instruments. We have the flaps and the slots, the horizontal trim stabilizer over here. You can use the horizontal trim of the aircraft, up and down, pitch down and pitch up. The aileron trim, the autopilot disconnect. So you see also the rudder trim here, the vertical stabilizer, the ailerons, the left and right wing aileron trim. You see the aileron trim position here, but the elevator trim you use the switch, and you see the position here. So we have The traffic now is closing in. And we have two aircraft for traffic here. One is closer than the other. So we have one plus 1,500. Satan is less than 5 nautical miles away from us, in front of us over here. So we have to use also the speed brakes of the aircraft. You can extend the speed brakes when the thrust levers are at idle. Like this. This is the takeoff ground switch. You can press this here. You will disconnect the auto throttle like this. So we can move also the, as I told you, the speed brakes when the thrust levers are at idle. Only if we have the speed brakes extended and the thrust levers are idle, when we move the thrust levers forward, the speed brakes retracts automatically. Also we have the flaps here and the slats up and down. The position of the flaps and the slats you will see here in the upper ACAS engine indication and crawler system display. So now we have another aircraft plus 400 feet, plus 300, and the traffic one more time. So you will see it here. This is the one aircraft we spotted in the navigation display. So you have to pay the attention here of the traffic collisions. So we have also you can move the thrust levers one at a time like this. So we have variable thrustles. So you will see the upper and the lower ACAS and the indication crawler system display. The N1, which is low speed starter and starts view. Now you see more pressure in the left engine than in the right. So this is the variable thrust. We can use also the other side for variable thrust mode like this. And now we have more thrust in the right wing engine. As you see, 35 versus 32. Also we have, we can use the same. We can also use as I told you, the auto throttle disconnect switch like this, the takeoff ground switch, and the thrust reverse. So if we press the thrust reverses, we have to use these controls and throttle. So we use the like this, and so this is gonna be the thrust reverse over here, and you see the thrust reverses deploy very fast. You see the reverse, and the blocker doors are open and slowing down the aircraft like this. With disarm, the thrust reverse, extend it again. Also the forward side in the same. And extend one more time. Also this side you see over here. Extend and retract. So this is the thrust reverse mode. So this is how you use these controls to slow down the aircraft. So we have also also the upper and the lower ACAS. We have the landing gear here, extender, retract, the alternate gear, the gear override, the rain override. You will see some warnings here not related to the engines. Also the flaps position here, you see this handle. So we have also the total fuel on board, the bleeder from the left and the right engine. This is the fuel flow to the left and the right engine, the fire extinguishers for the left and the right engine, the horizontal trim stabilizer position, the normal and the alternate trim tabs for the horizontal tail also, and you can see the position of the horizontal tail here. The green band is for takeoff. Also we have a failure of the hydraulics, the C1 or C2 over here. The autopilot and the auto throttle will have an auto train system, which will have to be disconnected here using the C and the R, the cutout switch position. So you have to move from the normal to the cutout if you have a failure of the hydraulics, the control, the auto trim function of the autopilot and the auto throttle over here. So this is the hydraulic. So we have also the thrust levers. You can move the thrust levers up and down. You will see the engine's function. So you will see the N1, which is the low speed starter and stop, the low pressure compressor and turbine, the left and right engine, the exhaust gas temperature per engine, the bleeder from the 5th and 9th stage of the engine, the Boeing 777-300, the mark here, the N2, which is the high speed starter and stop, the high pressure compressor and turbine of the turbocharged with the engine, the fuel flow per engine per hour, thousands of kilograms or thousands of pounds for the pressure, temperature, quantity, and the vibration of the N2 stage of the engine. So we move the thrust levers, which is the thrust commanded by the engines, and also we use the auto throttle here, the autopilot and the auto throttle. So we have the General Electric 90 autos now. So we have the General Electric 90G90 So we have the General Electric 90G90 turbo with the engine installed in the aircraft, one the left wing, one the right wing for symmetrical thrust and redundancy. This engine also contains a gearbox with the FADEX. The FADEX are the full authority electronic computer control and monitor and display all the functions you see about the engine in the upper and the lower ACAS, the engine indication controller system display like the N1, which is the low speed starter and stop, the low pressure compressor and turbine of the turbo hunter per engine, the exhaust gas temperature per engine, the bleeder from the 5th and 9th stage of the engine, the pressurizer from the engine, also the N2, which is the high speed starter and stop, the high pressure compressor and turbine of the turbo hunter engine, the fuel flow per engine per hour, thousands of kilograms or in thousands of pounds, the oil temperature, pressure, quantity and vibration of the N2 stage of the engine, the FADEX also control engine start, engine shut down, engine failures, the fuel metering unit to the engine, the fuel oil and heat exchanger, also the pressure inside the engine. We have an overpressure that can open the outflow valves into a higher setting of the 5th and 9th stage to a higher setting to relieve the overpressure inside the engine. We have another pressure that can close them into a lower setting to increase the engine pressure. Also, if we climb the aircraft from the sea level all the way up to the cruise level at 20, 30 and 30 and 40,000 feet above the sea level, as we climb higher, the air pressure density and the oxygen level is about half or less than that of the sea level. Also, the temperature of the air is freezing, it's minus 30, 40, 50, 60 degrees below zero. Also, the aircraft flies at an airspeed rate like 2 or 3 times faster than that of the sea level, so as we climb higher from the sea level all the way up to the cruise level, or if vice versa, we descend from cruise level down to the sea level, we have to change the fuel mixture manually, so this is done automatically in this aircraft using the FADEX, which controls the fuel mixture. So it's a good thing to have the FADEX installed in your jet aircraft engines. So we have also so this is all for the FADEX and the engines. Now I'm gonna talk to you about the Newton's first, second law kinematics of motion, about the new theory of fluids and aerodynamics, and I will show you the flight controls of the aircraft. Then I will make the engine start, and then the flight management computer, and a complete flight from takeoff, climb, cruise, descent, and approach and landing. So I will show you now. You can see the outside view of the aircraft. You can see the surface area of the wings holds the weight of the aircraft as it flies. Also, you can see the airflow. You can see the mean aerodynamic chord position over here. The Mach is 35% of the chord of the forward wings is the position where the maximum aerodynamic lift or maximum pressure occurs, and also where the stall, the airflow of the air mass above the wings becomes detached from the wings. It's also the position where the center of gravity transverses the airliner aircraft over here. Also the longitudinal axis from the nose to the tail, and we have the lever arm is times the distance from the center of gravity all the way back to the horizontal or vertical tail over the airflow of the air mass per second times the acceleration of the air gravity, and you have the lever arm and the moment arm. Also we have the vector from the engine that propels the aircraft forward. Also you can see the wings of the aircraft. The bottom surface is more flat, so the airflow of the air mass using the Bernoulli theory of fluid is moving slower below the wings, which pressurizes the aircraft wings up into the air in takeoff. Also the top surface of the wings has higher curvature, so the airflow of the air mass is moving much faster. Again, we have difference of pressure. The airflow of the air mass is moving faster, so we have lower air pressure above the wings, which pressurizes, which sucks the aircraft up into the air. So I'm gonna show you now the flight controls of the aircraft. So I will show you also the side stick I use here. So you can see here I'm having the Logitech Extreme 3D over here, so I can climb, I can descend. You can see here. So I will show you the side stick I'm using. For this I'm using the Logitech Extreme 3D over here, so you can climb, you can descend, you can bank roll left and bank roll right. Hope you can see it better like this. So you can see that both sides are interconnected. The first officer and the captain. So you can climb, descend, very easy. Also side turns like this, the ailerons, the spoilers, and the thrust levers over here. So you can move the thrust levers like this. So you have the thrust levers, the propulsion moving forward and aft, and simultaneously using the flight controls to fly the aircraft. So you can see the side stick deflection is proportional to the yoke deflection over here, to the flight controls deflection. Also pitch stream stabilizer here. So this is the view from inside the cockpit about the flight controls. Now I will show you the outside view doing the same principle. So you will see here the flight controls movement like this. Bank rolls left, right. Also the tail, climb and descend. Takes maybe a second. The rudder pedals, the vertical stabilizer also left and right there. So this is how you control the aircraft. Now I will show you the overhead panel and make the engine start demonstration. So we have a few more minutes for this. for going into the flight phase, so we need only to come over here and this side over here, the upper panel. So we have a nicer view here of the cockpit. As you can see, the controls, also we can set the flaps for takeoff over here, like flaps 15, 30, 15 over here. You will see the 15 degrees over here, the flaps. You can also see all the instruments again. So here you see we have the hydraulic fluid disconnect for maintenance, the circuit breakers, the electric system circuit breakers. Here is the ADIRU, the air data inertia reference unit, on and off, the thrust asymmetry compensator, the primary flight control computers, the APU, the auto start system, the left and the right engine, the electrical power, the battery, the APU generator battery. So this is the electric system. This is the window heat, passenger oxygen, ground proximity, rammer turbine, the hydraulic fluid. We can turn off the hydraulics like this. You will see some failures over here generated. So we have a few more minutes. So we have the hydraulic fluid over here lost. So we have some systems lost. So we have alternate flaps. We have the stabilizer, flight controls, hydraulic systems C, R, and L. No brake, auto speed brakes. All these flight controls, thrust asymmetry compensators. All these systems are lost and more because of the hydraulic fluid. So we turn on the hydraulics again, and then to the auto position. So this is the electric, the hydraulic, the rammer turbine, the fire extinguishers, the electronic engine control for the engine. Over here, normal and alternate auto start system. We can dump some fuel to lose weight if we arm this, and select the nozzles also, how much fuel to remain. The left wing, right wing fuel tank, center tank is empty. The crossfeed valve. So this is the fuel system for the aircraft. The center tanks are empty. Also the wing and engine are the eyes on and auto. The cabin pressurization system, normal and alternate, and use the outflow valves, climb and descend, open and close to increase or decrease the pressure. Also the left, the APU we need for starting the engine. This is the pressurizer system. So you will see a couple of faults too over here. Also the no pressurizer, and we lose the hydraulic fluid C1 and C2. So we turn on. We cannot also start the engines like this. So we need to come here again. Make the auto start system, the engines. So this is the upper and the lower display, the systems, and the flight management. Here we're gonna set up the flight plan. So we turn on this display, the engines, the status. You can see the APUs running, the hydraulic and the oxygen level, the checklist, mode, the normal menu, the non-normal menu, we have a failure, the communications, navigation, synoptics, the doors are closed, the cabin can be pressurized, the landing gear, you can see the temperature of the brakes and the pressure of the tires, the electrical. I show you in the overhead panel, left engine, right engine, backup generators, the voltage. Over here the APU is running, the hydraulic fluid, left engine, right engine. When hydraulic fluid goes on the backup hydraulic, 3000 psi, the fuel, left wing, right wing, cylinder tank is empty. You can see the left and right wing, low and high pressure fuel valves. Total fuel on board, left wing and right wing is balanced. You can see the minimum fuel temperature. Below it's the fuel cases, and the APU is fed from the left wing tank. The air system, the left and the right wing, and the APU I talked to you about in the last, the flight controls. We can control, we can see the flight controls over here, like this. Everything is working normally. So we have only a few more minutes for this video to end, so we go back to the engine, make the engine start demonstration very fast, turn off both engines, so you will see the reconfiguration in the overhead panel. Also the engine set on over here, engine set on, engine auto start, engine set on. There is no fuel flow right now, over here is 0, so you see outside. You see left and right wing engine is running because of the pressure right there, so we start the fuel again, so you will see the fuel flow from 0 going up, and we have both engines, right and left wing, spinning with pressurizer and with fuel. So we can start the flight plan, the last part, before going into takeoff. Over here we need to set up the flight management computer. So we have the menu, you can see position initialize, initial fuel, 0 fuel weight, the reserves, the cruising altitude, the cost index 100%, and the route from this airport. Lszh 8, back into this Lszh runway 14. So we have the departure and Lszh 14, transit to Alpha, and arrival Lszh 14, transnegrial on Alpha, transamity. So we clear it here, the discontinuity, activate and execute, and we have the flaps and the center of gravity for takeoff, and the V-speeds 133, 140 and 154 over here, the takeoff speeds for takeoff. This goes waiting this runway. So we advance, disarm the parking brakes, advance the thrust level. We already have taken the clearance for takeoff. So we only advance the thrust levers and use the tiller also. The steering. So this is our runway for takeoff. So we have taken over here the clearance for takeoff, and we can only align with the runway. The flaps are set, parking brakes set over here, the LNAV set over here, flaps set, the terrain, you can see here the distance and the flight plan. Also the flaps and the horizontal stabilizer, we need to move all the thrust levers over here forward. You will see all the information is ready on the engine. So if we look outside where we are right now and where we're going, so we are ready for takeoff. We only have the warning for the parking brakes, disarm the parking brakes and go. So we have 90 knots, 100 knots, align with the rudder pedals. V1, we rotate, it's a little bit up for the rotation, and we have the positive rate of climb over here. landing gear is up, and we need to pitch down a little bit the aircraft. So we have the positive rate of climb. So we are 2,500 feet above the ground level, 4,400 feet above the sea level. The rate of climb of the aircraft 6,000 feet per minute. The airspeed 200 knots, 239 knots. The ground speed 233, and we climb to this airspeed and this target altitude. You can see where we are right now as we climb out, and we have 14 more minutes. So we need to start making a turn. You can see the stall speed here. The airspeed is 190 knots. The stall speed is below that as we turn is 140 knots, and the warning is 145, 150. So we need to increase the airspeed a little bit as we climb, making this turn. Also we have the outside view of the aircraft, the beautiful view of the bridge. Over here we fly now with 250 knots and make a turn. So we also have a beautiful view like it. We fly with about 600 kilometers an hour, about 215 meters per second. This is our beautiful Boeing 777 and the great view over here. So now we need to start making a turn again, another turn. We follow the flight plan as we climb out 15,000. This is the rate of climb. Over here we have an overspeed warning. So we cross 19,000. So you can see the star sign here, the lake. And we have this beautiful galaxy view. So we crossed 32,000 feet and we have like 10 more minutes. Papao σε 15 λεπτά.
Άντε σήκω.
Σε 15 λεπτά.
Μάλιστα τα σεντόνια τα ρούχα εκεί απάνω και έχεις χρωματισμένα να τα πίνεις.
Σε 15 λεπτά. $34,000. So we need to balance here. So we have the Germany in front of us, the Bayern Munich over here, Germany, as you can see, and the France on this side, also the Switzerland on this side. So we have the Germany, the Bayern Munich, and the Bavaria in front of you, and this beautiful galactic view and the frozen vapors, the countries and the countries. As you can see, we fly with almost 250 meters per second, or about 600 kilometers an hour. So we have also the St. Gallen, the lake here. We need to start making a turn. We need to advance the flaps up and the airspeed up. So we're cruising here, 35,300 feet, and also we have this beautiful view over here crossing the Germany, Bavaria, as you can see. So this is our spacecraft for tonight, the Boeing 777-300ER. We fly with 900 kilometers an hour, 300 meters per second. Over here, the beautiful Boeing 777-300ER, and we have the frozen vapors. All the chemicals in the controls, as you can see. So we need to start our descent plan over here. And we can connect also the autopilot and so we are 35,000 feet. Autopilot is on. Increase the airspeed and also the altitude for descent. So going back to the cruise level, from the cruise level all the way down to the airport elevation. So we're gonna start descending now, as you can see. And we have 36,000. And we descend with this rate over here. Also the speed brakes over here. So we are approaching for the landing. We are inside the runway. We have the Lszh localizer. So here we are. This is the localizer. And we need to descend, and we have 2 more minutes left for this video to end. So we use manual flight guidance and also flight controls manual. So we are inside the localizer. Idle thrust. Ready? 10. Here we are, first touchdown, parking brakes, and reverse thrust. Full reverse thrust. Here we are, slowing down. As you can see, a beautiful landing was needed. You can see everything is normal. The nose wheel, there is no breakage of the wheel. Also the